The conversation you're about to hear was recorded live at TWIMLcon AI Platforms. For more coverage of TWIMLcon, visit twimlcon.com/news or follow us on Twitter at TWIMLAI. But first, a word from our sponsor. Thanks to our friends at Dot Science for being a founding sponsor of TWIMLcon AI Platforms. Dot Science is excited to have met so many amazing attendees at this year's conference and looks forward to continuing those conversations. If you weren't able to connect with their team at the conference or are interested in what you heard on stage or at their exhibit in the community hall, head over to dotscience.com/deploy for a free demo and see just how easy it is to get your models into production and keep them performing. So please take the opportunity to join me in welcoming our first guest. Hussein Mehanna is the head of artificial intelligence and machine learning at Cruise. And Hussein has a very unique set of experiences that I'm excited to dig into in this interview. He was founding engineering leads on the Facebook's FB Learner platform, went on to Google to work on Google Cloud, and now is running ML and AI at Cruise. Hussein, welcome to TWIMLcon. As I mentioned in the intro, you have had a very unique set of experiences in this space, starting with joining Facebook at a really pivotal time, I think, for the company. Clearly, before there was a machine learning platform and helping get that effort launched. Tell us a little bit about those, that time period that you were there. I imagine it was a crazy period, and you've got some war stories.
It was 2012, and I think it was the really best time to work on machine learning at Facebook at the time, because the product was mature enough to support machine learning. Before you can do machine learning, you also need good data infrastructure. But the machine learning platform and capabilities themselves were very little. So at the time, there was probably maybe 2 algorithms at most, probably maybe 20 people using machine learning at Facebook, and maybe over an entire year, maybe 20 models were trained. By the time I left, we had 25% of engineering using machine learning, so we were in the thousands. And we were training maybe 2 to 3 million models a month. And a big portion of those were automatically trained and triggered, just like whenever new data comes, they just got launched. And most important metric of all is the time it takes to ship a model from idea to production. Mm-hmm. A relatively simple model would take 3 months, 4 months in those days.
When you started?
When I started, and then we got to a point where multiple models a day could be launched.
Wow, that's incredible. So the early models were, I'm imagining, ads and feed?
Yes. Ads and newsfeed and search at Facebook are the biggest consumers of machine learning, and they continued. But the earliest models were very, very simple, very rudimentary. But by the time I left, we've supported sort of all sorts of algorithms and models you can think of.
I can imagine. So when you got started, how big was that effort? Was there a minimum viable product for the platform, or?
There was no Facebook-wide platform. There were sort of pockets of people who decided that they had to work on a platform for their team because they just couldn't ship anything. And I became one of those. There was a small tool that we had, and I went to my manager after several months working in the ads team, and I said, you know what, I'm just going to focus on the platform. It is our biggest bottleneck. And so I started working, and I remember the first thing I shipped, I locked myself for 3 weeks. We were training a simple boosted decision tree that took 3 days. And when I got it down to 21 hours, I could just see the tears of joy because my peers were like, "You're saying I could train a model in a day and get the results in a day, in the morning, and then just be done?" Like, they were extremely happy. And we eventually got that down to 2 hours. And so, you can see a correlation between sort of the innovation we had and the productivity that machine learning engineers had. So I decided to focus on that. And then as the journey of the platform evolved, we realized that there's an opportunity to support applied research. Because now when you have a platform that unifies the company, if you drop in a advanced algorithm, everyone else can use it. And so the platform supported applied research in a great way.
And so the work you did with the boosted decision trees, how did you achieve that speed up? Was it just working on the algorithm itself, or was it scaling it some way, distributing it?
A combination of everything. So the first early wins were mostly about just avoiding some inefficiencies. Often machine learning data scientists or machine learning scientists are not the best infrastructure builders. And so there was just very common mistakes. And those were the early or low-hanging fruit. But eventually we got to a point where it was all about making the algorithm itself faster. There's a paper that Facebook published about ImageNet in an hour. That's an example of how such scaling efforts eventually evolved, where it wasn't just about the infrastructure, but it's also about exploring different algorithms, learning algorithms that can speed up the training overall.
Did the speed for training a model versus cycle time, what ended up being your driving metric? What was the thing you were really focused on?
That's a fantastic question. It's the end-to-end machine learning cycle, all the way from the moment you prepare your data to generate your features, to training your models, to deploying, and then back again. That cycle was essentially our entire focus, and moving through that cycle faster and faster meant that we're essentially building models that are learning faster, because that cycle itself is one cycle of learning in reality. So we focused on the entire end-to-end.
We talked about the MVP. Can you talk about the evolution of the platform there?
Yeah, we went through 3 phases. In 2012, I focused on what was at the time called Ad Learner. That was just for ads. And it became really successful that other teams started coming to us and saying, hey, we want to give up our platform, start using your thing. So that's when we moved it to FB Learner, and we had like 2 other groups at Facebook. But then we realized that, so we were scaling on the dimension of teams or scenarios, but we're not scaling on the dimension of algorithms and techniques. So it was a platform basically based around a couple of algorithms. So we then moved to the 3rd generation, which is FB Learner Flow, and that's when we scaled the number of scenarios significantly and the number of algorithms that we support. And we built that platform with extensibility from the get-go. And not necessarily extensibility by the core FB Learner team, but by the entire company. And that's when the adoption rate in Facebook picked up. One of the things I'm really proud of is that we balanced flexibility with ease of use, that we had about maybe 100 to 200 users from Sheryl Sandberg's org, and their finance and business. And so we're really proud about democratizing machine learning within Facebook to that extent. At the same time, we had the latest convolutional nets, we had deep learning for NLP, so I think we successfully built a good multi-layered platform that scaled for different use cases.
So you just mentioned use cases. You started with a teams dimension and an algorithms dimension. Do those 2 get you use cases, or is there another abstraction that you thought of where you're trying to generalize a use case beyond a specific team and an algorithm?
Yes, so if we talk about abstraction layer, FB Learner Flow's contribution, I would say, and we talked about this on Facebook blog, is I think we nailed the right abstraction. It's a workflow. And a workflow consists of an operator that takes generic data, whatever data types you want, and gives generic outputs. The nice thing is that once you have an operator, you can create any workflow you want. But what's even more powerful is the entire workflow can become an operator in yet another workflow. And this composition allowed us to build multi-layered platform. Let me give you a concrete example. So let's say you build a convolutional net that takes in an image and produces a model that classifies based on the data and the labels you offer. That in itself is extremely powerful, requires someone who's deep in convolutional nets and deep learning, but at the same time it's still hard for a lot of other machine learning users, even data scientists, to use. So what you can do is you can wrap that in another workflow that simplifies it by saying, just give us the data and we'll do hyperparameter tuning on your behalf. And then you can wrap that with another workflow that makes it more useful from a business case. So filtering images in different scenarios, like if you're filtering them to remove explicit content, is different than if you're filtering them to propose an image for you to share later. So these are all different use cases. So essentially that multi-layering allowed us to scale. And the most important part is making everything shareable and reusable. So whenever some team builds something, every other team at Facebook has the opportunity of reusing it. And to make it reusable, we had to make it discoverable. So we created search. We would rank these workflows by how many times they've been used, how many times they've been successful, so that the rest of Facebook, which started growing into the thousands, would know like, oh, this is the most popular convolutional network workflow, or this is the most popular text classification workflow, and so on. So that was very useful at Facebook, and it helped spread adoption.
Facebook, in a lot of ways, has demonstrated a huge commitment to open source and openness generally. If you look at the kind of the bottom of the stack, they do open compute. At the top of the stack, they're doing things like PyTorch and Onyx, but they haven't, open sourced the platform. And I've had conversations on the podcast with folks on the team, and while I didn't ask this, my sense was that a lot of the way things are done or work are very Facebook specific. Like, there was no Kubernetes when we started this,
That's
so we
right.
were doing our own distributed compute, the connections to data. Is that kind of...
Yeah. No, that's absolutely right. Once you start going into end-to-end machine learning, unlike PyTorch, which is heavily contained, the integration into whatever infrastructure system you have is a much bigger component. And so when we were looking at open sourcing FB Learner Flow, we had to open source the rest of Facebook with it. Now, the beauty of Kubernetes is that it gives you this abstraction layer. And through my time at Google, we invested in Kubeflow pipelines, which is, you can think of it as a moving workflow engine that you can take with you wherever Kubernetes exists.
Yeah. Speaking of Google, after Facebook, you went to Google. Can you talk a little bit about your role there?
So I was very passionate about building machine learning and helping tools or platforms and helping others adopt machine learning. And frankly, there's no better place to do this than being at Google because of its amazing machine learning brand, amazing machine learning research capabilities, and Google Cloud. And so that trifecta was extremely exciting for me. And I joined Google, and I just, like, my time at Facebook was extremely amazing, but then seeing the plethora of machine learning use cases from healthcare to autonomous vehicles to finance and so on, just was fabulous and amazing. Like, there's a lot of diversity in machine learning.
So you joined Facebook in 2012 and Google in 2017. They had this amazing machine learning brand. The work was all done. They were much further along.
Google, you mean?
Google?
So not necessarily. Actually, Google and Facebook, their investments in machine learning follow their strategies. So let me explain what I mean by that. Google has a very broad set of products, like documents, doorbells, cameras, you name it. Facebook is far more focused.
Okay.
Right? And so when you look at machine learning investments, Google has a broad portfolio. Facebook is far more focused. There are places where Facebook is better or advanced, and vice versa. The nice thing is that the two are complementary. So I'll give you an example. I think PyTorch demonstrates Facebook's focus on usability and ease of use. But then you look at Google's broad portfolio of research, it demonstrates its breadth. So I won't say one is better than the other. They just have two different styles that they've inherited from how they invest in technology in general.
One of the themes that's recurred in my interviews here and beyond this conference is the idea that right now productivity in machine learning is primarily a usability challenge as opposed to a modeling challenge, for example. Would you agree with that, or?
I agree to a very large extent with that. That's absolutely right, and that's one of my pieces of advice that I give to people who are trying to build a new platform. it's not necessarily about sophistication because your end customer may not need it yet, right? Your end customer might have a usability problem. And through Google Cloud, we found that different customer types had different usability issues. Even the very sophisticated customers who would come to us and say, just give me GPUs. Even the usability of giving them a GPU easily and clearly meant a big difference to them. So I think my advice is do not ignore usability. Machine learning is obviously a very deep technical area, but approach it with a product sense. And that's why at Google and at times at Facebook, designers and user experience experts were my friends because I would ask them to help me figure out where are the usability bottlenecks that users are suffering from. And then if we solve them, you see massive increase in productivity.
Are there examples of where designers have kind of come in and changed the way you thought about a problem?
Absolutely. So one example is at Google. We had a fantastic user experience team, and we were building a lot of great machine learning tools for text and image and so on. And then what we noticed is that our users wanted to combine all these together. Right? And so we deployed our UX team, and they would sit with our users to go through an end-to-end machine learning workflow. And those users are other companies. And then when we showed them these end-to-end workflows, you could see how just things click in the eyes of our users. They're like, oh, I understand why it takes so long. Because I would spend so much time in this part, like preparing data, when I thought that the hardest part was using TensorFlow. But I actually need to invest in improving this. So that was one of the examples, and it just happened again and again. It became our most favorite topic with customers, that customers would come to us and say, where's your UX team? So it was really interesting.
Awesome. So you've been at Cruise for about 6 months now?
Yes.
What's why Cruise and what's your role?
Yeah, absolutely. So I started in machine learning in 2012 when things were just ramping up and not a lot of people thought that machine learning is the sexiest thing. I actually see another trend that is about to happen, and that's the domain of autonomous vehicles. I think that's going to push AI to a whole new level in terms of the depth of the problem and in terms of scale. So let me give you concrete examples. Most of the machine learning applications that are dominant in the industry today are either advertisement or recommendations for movies or products. And these are very decent and extremely impactful applications. But if you compare them to what a car needs to do to navigate the roads of San Francisco safely, the decision making is maybe an order of magnitude less. So the car has to track so many objects, including pedestrians, funny pedestrians who might be wearing a palm tree costume. The car needs to have common sense.
That happens here in San Francisco?
It happens here at San Francisco. I've seen a gentleman who had a bike with a 4-trolley system behind him. So you see a lot of these interesting things. And then the car needs to predict what these different agents are going to do. And so the decision making is very complex, and you need to do that in 100 milliseconds. So the problem is far deeper, and that just pushes AI to new limits. The other thing that is really important is the accuracy required is very high in order to drive a car safely. No one gets hurt if you show them a bad ad or a bad recommendation, right? And what's interesting is that you can learn from that, but in autonomous vehicles, we have to push our accuracy limits. And then finally, every car moving in the street has multiple sensors. So they have multiple cameras, multiple LiDARs that are generating gigabytes of data a second. And when you have multiple cars of these roaming around, the data scale is actually giganormous.
So scale is an interesting point. We had a really interesting exchange early on when we were talking about you participating in the conference, and I kind of approach you with, hey, you were at these huge scale places, Google and Facebook, that nothing's bigger than that, right? And you're like, hold on, autonomous vehicles is way bigger scale.
Yes.
Elaborate on that. How do you think about the two relative to one another?
Oh, absolutely. Here's a way to analyze scale. If you look at your training data, right, don't just look at the number of rows, but look at the size of a record. One record. Most of the time, when you leverage recommendations, it's tabular data. The record size is not huge. But if you look at the record size for an autonomous vehicle, it could be thousands of LiDAR points, multiple, tens of thousands of pixels. Even audio matters because the car needs to listen if an emergency vehicle is coming around. We actually need to figure out if a pedestrian is waving to us or looking at the car or looking at the phone. So the record is just far bigger. So that's one example of scale. There's another thing that is interesting. Machine learning is just part of the application it's among. So in web development or web-based applications like recommendations, the tool chain is well developed. In autonomous vehicles, we're still innovating that. We're still building it. And we're still trying to scale to the amount of data. And that's one other example of how scale matters in autonomous vehicles because the tool chain doesn't yet exist. We're inventing that as we're inventing the cars themselves.
Are scale and the need to build out the tools, are those the only challenges that you face, or are the problems themselves inherently challenging?
All of them.
Clearly they are. In what ways?
Yeah, I mean, you get into a cycle of like, I can solve this problem if I could just scale. And then after you scale, okay, I solved this problem, now I discover a new problem and I need to scale further. So one of the things that attracted me to the company is this understanding the interplay between the applied research problem and the underlying tooling. And that's why our co-founder Kyle says he's building two things. He's building the car and he's building the tools that are going to build the car because no one has built that before. If you compare this to the web world, the tool chain is far more mature. We've been building web applications and mobile applications for a couple of decades now. And so the tool chain is far more mature, but you look at autonomous vehicles, that's just not there.
At Cruise, your approach is multimodal in terms of the types of information that you're taking in off the vehicle. You've mentioned LiDAR, you've mentioned imagery, you've mentioned sound even. Within all of those, are there specific categories of problems that are key or?
Oh, yeah. Yeah, I can list so many. I mean, the basic is just detecting objects in the scene, understanding that this is a car and that this car is heading this way, understanding whether this car is moving or not. You have the same problem for pedestrians, bicycles, and now scooters. And all of these agents have different behaviors. And it's not just enough to say, this is where they're at now. You also need to predict what are they going to do in the future. And so behavioral prediction is also another problem. One of the other interesting areas to apply machine learning, which I don't think people know a lot about autonomous vehicles, the style of driving, how fast you brake and how fast you accelerate, may not necessarily affect safety, but affects your experience as a rider. So because if you brake hard, the riders may get nauseous.
Right.
And so the driving style.
So my wife tells me.
Exactly. And so the driving style itself is a machine learning problem. I mean, I think it's a Pandora box. Like, frankly, I went there because the number of machine learning problems is just endless, and I think it will be an exciting place for anyone excited about machine learning problems or machine learning tools.
And one of the ways you were introduced to Cruise is that they were doing some of their work on the Google platform. Can you talk a little bit about how you're platforming the machine learning at Cruise today?
So Google Cloud, we offered multiple sort of suites of products to our AI customers. Cruise is obviously an AI company, so they were mostly focused on the lower level infrastructure like GPUs and some tooling around it. I remember my first meeting with Cruise, and I was like, okay, well, I'm getting introduced to these people. They seem really enthusiastic. And then I look at our numbers, and I start seeing the GPU usage, rocketing up to the extent that we had to go and, scramble to get them more GPUs. And I was like, something is happening there. And for me, a company's focus on machine learning by how much they spend on the infrastructure and how much they use it. And so it was very clear to me that something big is happening there. And then I visited them a few months later, and the progress rate was phenomenal. So I joined there a few months ago, and it was 8 months into building their own machine learning dedicated platform. And it just advanced really quickly. And just in the 5 months that I've been there, it even advanced further. So I'm really glad I'm there because the problem is deep. The pace is really fast. And that's something I enjoy, and I think it's very important for machine learning. And I get to, again, redefine what the future of machine learning, I believe, is going to look like. Because I believe in just like ads and recommendations propelled the application of machine learning in the industry the last 3 to 5 years. I think in the next 5 years, it's going to be robotics and autonomous vehicles. And it's going to push machine learning to levels we haven't seen. And I'm really excited about that period. I think machine learning and AI will fulfill their promise through the vehicle of robotics.
So you're bringing an incredible wealth of platform building experiences to a new problem, one that has unique challenges. How do you customize, what you've done before, what you've learned, or what you believe about, delivering platforms to that specific problem? Both generally, philosophically, but also, concretely, what does the Cruise platform look like?
Sure. So I think for Cruise particularly, and this is something I did super well at Facebook, it's the interplay between applied research and platforms. How can you scale applied research by shipping it through a platform? Because applied research in machine learning is costly, and you don't want every team, every sub-team to do their own applied research. What you'd rather do is, if one team innovates, you want everyone else to use it. And so that interplay is important.
Is applied research your primary user at Cruise, as opposed to data scientists, machine learning engineers that are
both
another function? Or?
All of these are all in my org. So the applied research part of the autonomous vehicle, the data scientists, and the machine learning platform are all one community. That's essentially Cruise AI. And that's one of the things that I think is unique about Cruise. Often you see companies who split the two. In the early days of Facebook, these were combined. Google also, the machine intelligence group is also a combined group. And I think that approach is really important because the platform evolves through the demands of the research scientists and the data scientists, but also the platform has an ability to influence them and improve their research. So that sort of yin and yang is very important. In terms of general advice about a platform, I would say first thing is what I mentioned, bring your scientists and your platform builders together. The second thing is be extremely customer driven. Sometimes it's enticing to chase a very sophisticated scenario, but that may not be what you need at the moment. So be customer driven. The third thing is be careful bringing biases of other experiences. So I often seen that big data techniques failed for machine learning. So as an example, if you use MapReduce, it doesn't scale as well as one GPU machine. And I had this example at Facebook where there's a sophisticated graph processing system. It ran on 500 machines, and it ran slower than one single machine, and ran even much, much slower compared to one GPU. So bringing some of these biases is dangerous. And then finally, I believe a proper platform is an algorithm-agnostic platform. That's the basic minimum level of extensibility that a platform has. If you build it around an algorithm, machine learning changes so much. What is hot today is tomorrow's tomorrow's deprecated algorithm. And so if your entire platform is basically based on a bunch of them, then you're going to be wasting a lot of work and effort.
A lot of teams struggle with this generalizability aspect that you're mentioning. Do we support a specific framework? Do we support a bunch of frameworks? Do we support specific algorithms versus a bunch of algorithms? Do you think there's a certain scale that you have to be at before you can afford to be general, or is that something that you need to commit to independent of the size that you're at?
Well, it depends on the company. I think we made an early decision in 2014 at Facebook that we are going to generalize because it was very clear that the company is going to require different algorithms, different use cases, and we don't want to reinvent the wheel. But maybe different companies have different circumstances. So just work it backwards from where you think the customer will be, not today, but in 3 years. I believe companies like Facebook, Cruise, Google, and so on will benefit from a general platform. Smaller companies may benefit from more specialized platforms. Like if you're a fintech company and you know you're not going to be dealing with images at all and there's no value for you, then focus on tabular data and build your platform that way. But if you're a company that has mixed sources of data, very likely you need to generalize.
Curious about how you approach the organizational side of things. You mentioned that you've got all of the kind of key customer groups in the same org as the platform, and that's key. Are there other things that you've learned or believe organizationally that are required to make this successful?
Yeah, over my time at Facebook and Google and in Cruise, I've ran organizations for AI that consisted of different functions, not just machine learning experts. And my advice is treat all of them equally. You need them all to deliver a good machine learning product. And so, as an example, at Facebook, one of the very early decisions, we realized that machine learning has a usability problem, so we need to hire user interface UI people, and we elevated them to the same level as our researchers because they didn't want to join a team where they felt they're going to be second class. So I'm a big believer in this cross-functional mixture of talent. And actually what's interesting is each function brings its diverse perspective, and that aggregation of perspectives creates really fantastic machine learning products.
So where do you see platforms going overall, or machine learning in kind of the enterprise context?
Well, I'm going to be biased because I've made my bet through Google Cloud. I think there's going to be a lot in Kubernetes, and that's the reason why we invested in Kubeflow. I think notebooks interacting well with machine learning workflows. That's why Kubeflow has a notebook solution and has Kubeflow pipelines. And then I'm very excited about the ability to share. So if someone builds an interesting machine learning component or an interesting machine learning workflow, how can they share this with the rest of their company or the rest of the community? So I think these pillars are necessary for successful machine learning platforms. And I believe cloud providers are going to play a very big role in that aspect. But I think it's going to be on Kubernetes.
Nice. I should mention that I have not seen them yet, but David Aronchik, one of the founding team members of Kubeflow, is here somewhere, and there's quite a bit of interest in a Kubeflow session in the Unconference. If that's of interest, definitely check that out. Hussein, thanks so much for joining us here at TWIMLcon AI Platforms.
Thank you very much. Appreciate it.
All right, everyone. I hope you enjoyed our show straight from the main stage at TWIMLcon AI Platforms. For more information about today's show, visit TWIMLai.com. And for more TWIMLcon coverage, visit TWIMLcon.com/news. Thanks so much for listening, and catch you next time.